So for Unit 7, I'm going to go through kind of everything. It's going to be multiple videos, so it's not going to be like 1 hour long video. But basically in Unit 7, what we're focusing on is graphing trig functions, solving trig equations, and then modeling with them. And in our modeling, we're going to have to be able to kind of do both of these. A couple things that you need to make sure that you know before going into Unit 7, so from previous units, you have to know the unit circle. If you do not know the unit circle enough to use it going backwards and forwards, then you're not going to be able to do this unit. You have to do coterminal angles. You're going to have to understand that one terminal side, you can get there with different angles, and they're all coterminal angles. And then you also have to know how to solve quadratics. If you don't know how to do any of this stuff, you're not going to be able to do this unit. So go back and review this information. Okay, so we're going to start with 7.2 and 7.3, and I'm going to do it a little differently. So we're going to look at those together. And basically this is what you need to know. So for 7.2, we did graphing sine, cosine, and tangent. And 7.3, we did graphing with the period. Now I'm going to focus just on sine and cosine with this video, and then we'll do tangents separately. So you need to know the parent functions, what they look like, and the general equations of the graphs. So if I look at the general equation, y equals plus or minus a sine or cosine bx minus c plus k. Now the amplitude is always going to be the absolute value of that a value. So if it's positive, negative, doesn't matter, you're taking the absolute value of it. Your phase shift is going to be bx minus c equals 0. You're taking what's in parentheses. Now a little side note is sometimes the b is going to be factored out, and that actually makes it easier. This is just a horizontal shift. So if you think back to quadratics, our horizontal shift just depended on that h value. So if b is already outside, you can just look here. The process would still work setting it equal to 0, but it does kind of make a shortcut. Now our vertical shift, we're going to focus on that as a mean line. So what line is in the middle? What is the average? So that's going to be the k value. And the period, and this is a transformation that you haven't dealt with before, most likely, is always 2 pi divided by b. Unless it's tangent, then it's pi divided by b, but we're going to stick with sine and cosine today. And then a new thing that I haven't talked about before is, it might help some of you, is x scale. So this is basically what's the distance between our kind of steps. So you always do period divided by 4. So with sine starts at your middle line, goes up, down, down, up, up, and it's going to keep going, and so you can go backwards as well. Cosine starts at the top, but it still follows that same pattern of, okay, we're at the top, so we go to the middle, bottom, middle, top, middle, bottom, and so on. So when I say amplitude, it's just basically if you took the maximum and the minimum values, so 1 and -1, what's halfway between that is 0. That's your mean line. What's the distance between that? Is 1. So the amplitude is what's half of the distance between the maximum and the min. That distance would be 1. And then the phase shift, there isn't phase shifts on these because that's moving the function left or right. And then the period is 2 pi. Now when I say the period, I've highlighted one period in yellow. on both of these. It's just where does the function start repeating itself? Not repeating values, because it starts repeating values on this one here. I have the same value right here. But where does it start repeating the whole thing? So that's where it would start repeating itself. And then notice that in the equation it's represented with a b. That's not the period. It's used to find the period, but you'd always do 2 pi divided by the b value. Okay, and then your scale, your x scale, and this is what I mean by x scale. So if I'm at the middle and I go to the top, what's the x distance between stepping? What's the x distance between stepping? What's the x distance between stepping? That's what x scale is referencing. Now on both of these, the domain is all real numbers because I can input anything, and the range is -1 to 1. Now that's going to change when we start applying some transformations, but that is the general idea for these graphs. Okay, and then go ahead and pause the video if you need to write any of that down. We're going to just do some examples. So we're going to start with y equals sine x plus pi fourths, and we're going to find our different information. So the amplitude, there's a 1 in front, so what is the absolute value of 1? It's just 1. Now my phase shift is going to be where you take this inside piece and set it equal to 0. So that's going to be -pi fourths. Notice that that's one of the cases where I don't really have a b value over here. So it's just this value, the opposite sign of h. So -pi fourths. And then what else do we have? The mean line. Well, technically this is +0. So I'm not moving this up or down anything. And then the period is 2 pi divided by that b value. Now the b value technically is just 1, so the period here is 2 pi. And then we can look at an x scale, where you take the period and divide it by 4. So everything is going to be the same for sine, except we have a phase shift. But I'm going to draw just the very general idea of the sine graph. Sine starts in the middle, and then it goes up, down, down, up, and then repeats itself. So when I draw my actual graph, we are going to, instead of starting at y equals, or at x is 0, we need to move back pi fourths. Now the x scale is going to help us kind of figure out how many little marks I need to go. So I need a distance of pi halves. So what is -pi fourths plus pi halves. Well, I need a common denominator. So this is really going to be 2 pi fourths. So what is negative pi fourths plus 2 pi fourths? Pi fourths. So that's where my next step is going to be. So let's mark that on the graph. So there's my pi fourths. And then let's take pi fourths and add another 2 pi fourths to that. And I get 3 pi fourths. So 3 pi fourths, and so on. So basically, every 2 marks, we're making a step. So sign starts at the middle line, and then it on the next step goes up, and then on the next step goes down. Nope, to the middle. Next step goes down. So I'd have to extend this graph to get the whole thing. Okay, we can extend it. And then I need 2 more marks to get back to the middle. Now if I was going to continue going backwards, that's where it would be. So this is the graph here of our function. Now for some context, if we didn't have that phase shift, what this would look like is, so that's what the graph would be looking like, but going, of course, in both directions. Because typically we were saying, okay, so then it would be over here. Sine has a period of 2 pi, so halfway between that is pi, so that's our half mark. Halfway between that, it's at the maximum. Halfway between these two, it's at the minimum. And all we've done with this one is shifted this back by pi fourths. We can also do a graphing calculator of this. So I'm going to do y equals. We'll do just the very basic parent function. And then we had sine of x minus pi fourths. Oh, plus pi fourths. I'm going to actually hit zoom trig. It's going to give me a better window to kind of view this at. So that's our sine function. And then that's the sine function where we've shifted this by pi fourths. Okay, and then if we talk about domain and range, because we didn't move this up or down and we didn't stretch it in a vertical direction, your domain is all real numbers, your range didn't change, -1 to 1. Okay, so I'm going to make another video for some of the other examples.